Buildings, bridges, towers, and tunnels are among the few structures around us. Structures are built by connecting multiple elements. The connections safely transfer the load between each member and eventually to the ground through the supports. A designer makes assumptions and chooses the right connection and support types in a structure. A walkway at Hyatt Regency in Kansas City collapsed in 1981 and killed 114 people and injured 216. It is one of the infamous disasters due to connection failure. Hence, understanding the behavior of the connection type is important. The forces in a structure cannot be exactly calculated. Instead, an actual structure can be simplified as an idealized structure to understand its behavior. Also, using the idealized structure, the forces and the moment in the structure can be numerically calculated. For example, a tree can be simplified as a cantilever. Similarly, a tower can also be idealized as a cantilever, ignoring the shear deformation. If you carefully look at them, both of these structures behave similarly. Both are fixed at the base and resist the external loads by bending and shear. A free support can translate in three directions and rotate about all three axes. When an external load is applied to the structure would develop a reaction that opposes the tendency of the support to move. A force would develop at the support if it is prevented from translation. Also, a moment would be generated at the support if the rotation is restrained. In the following discussions, coplanar supports are considered to explain the basics. A support with one unknown is restrained in one of the directions. A horizontal roller is free to move in the horizontal direction and rotate about the joint. It is restrained for vertical movement, and a vertical reaction would develop while resisting an external load. The designer would have to consider this and design the support to resist the force. A cable exerts a force to the bracket in one direction, which is vertical in this image, and it is free to rotate and can move horizontally to some extent. A rocker or a roller support on a bridge can move horizontally and can rotate to allow the thermal movement. However, they are vertically restrained. A support with two unknowns is restrained in two directions. A pin support is free to rotate about its axis. It is restrained in the vertical and horizontal directions. Hence, vertical and horizontal reactions would develop at the pin support. A pin on the bridge can rotate at the connection, and it is restrained both horizontally and vertically. A fixed support, which has got three unknowns, is restrained in both horizontal and vertical directions and for rotation about its axis. Hence, together with the moment, vertical and horizontal reactions would develop at the joint. The girder in this integral abutment bridge is fixed at the abutment and cannot translate in any direction or rotate about the axis. Similarly, the counterforts in this dam are fixed so that they can retain the water safely. As a summary, in a two-dimensional plane, a support can be categorized as one with one unknown, two unknowns, or three unknowns. Some examples of support with one unknown are a rocker, a roller, or a cable connection. Support with two unknowns is a pin in a bridge. An example of a support with three unknowns is a fixed support in an integral abutment bridge.